In this video, we'll talk about monopolies. So monopoly lies on the other end of the competition spectrum from perfect competition, which we looked at in the previous chapters. Monopoly, rather than having many producers producing an identical product, we have only one producer. So, of course, if you only have one producer, you know who the producer is and what their product is. So it's an identifiable product, one seller, many buyers. And there's no perfect substitute to this product. So you can't just go out, buy something else. Monopolies are usually characterized also by high barriers to entry. And so there might be some sort of like very high permit cost or fee in order to start producing. Or sometimes we think about like power companies in rural areas as being what we call natural monopolies because the barriers to entry are so high, right? In order for an additional power company to start serving rural areas, they have to put up a bunch of power lines and power plants and things like that. Very expensive. Okay, so the monopolist profit is going to be defined the same as before, total revenue minus total cost. We're also assuming that the cost structure hasn't changed. So just like before, you'll be given some total cost function, and then ultimately you can take the derivative of that and find marginal cost. Right. We also know, just like before, that marginal cost equals marginal revenue. So again, and throughout this class, anytime we talk about profit maximizing, what is the profit maximizing quantity choice in particular? The profit maximizing quantity choice is always the quantity at which marginal cost equals marginal revenue. All right, so in the previous chapter, we showed why that is. There's a little graph. If marginal cost is greater than marginal revenue, the next unit you produce, you're losing money because then the cost of the next unit is greater than the revenue of the next unit. If marginal revenue for the next unit is greater than marginal cost, then you should produce that because the next unit brings in more revenue than it costs, so you're making positive profit. You keep producing until they're exactly equal. Right, so again, we know how to find marginal cost. It's just the derivative of total cost. So in this chapter, we'll talk about how to find marginal revenue for the monopolist. All right, what we're going to say is that as long as market demand for the monopolist is linear and downward sloping, which we're assuming it is, the monopolist's marginal revenue will have the same y-intercept and twice the slope as demand. So to show this, I have sort of a general proof. If market demand is linear and downward sloping, we can write in slope-intercept form, P equals form. Here's our intercept minus our slope times Q. Right, so our total revenue would be P times Q. Here's P, multiply our price times quantity, and then we just distribute this Q. Right, so here's our total revenue. If the market demand, and remember the monopolist will face the entire market demand, they're the only producer in the market. Right, so monopolist faces this entire market demand, and that differs from the perfect competitor. So we know that the market price is going to be a function of the quantity choice for the monopolist. Here is that price times quantity, giving us total revenue. And then if we take the derivative of total revenue with respect to Q to find marginal revenue, we get negative 2mq, or negative 2 times the slope times Q plus our y-intercept. So compared to our original market demand, we have the same y-intercept and 2 times the slope. All right, so for the monopolist, there will always be two ways you can go about finding marginal revenue. Again, you should know how to find marginal cost from the last chapters. There will be no changes that, just a derivative of total costs. Marginal revenue for the monopolist, you can either compute total revenue as price times quantity, or the market demand times quantity, or you can just know that as long as the demand curve is linear, that the marginal revenue curve will have the same y-intercept and twice the slope. So let's look. If we have this market demand, what is the monopolist's total revenue? Well, here's our price. Price equals this as a function of quantity times quantity. Distribute the Q, take the derivative. We get the same equation with double the slope. 2 times 1/10 is 1/5. Right, so how to find the marginal revenue for the monopolist? Again, 2 ways. Find total revenue and then take the derivative, P times Q, and then the derivative. Or you can just start with the market demand and know that it'll be the same y-intercept twice the slope. So graphically, the profit maximization question for the monopolist will boil down to 2 steps. The first step is exactly the same as what we've been doing. Marginal cost equals marginal revenue. That gives us the profit maximizing quantity. In this case, it's 10. MC equals MR right here. So we find the quantity. Right. Again, this profit maximizing rule, MC equals MR, always gives us the profit maximizing Q. So we find MC equals MR, and the monopolist could charge this price. This is the price where their MC equals MR. It looks like it's about 20. But for the monopolist, demand is not the same as marginal revenue. Marginal revenue is twice as steep. For the perfectly competitive market, for the entire market, demand is the same as marginal revenue. And that's the same for the individual perfect competitor. Right, so the change here, no change to marginal cost. We're assuming some sort of marginal cost, average cost structure, which is increasing like before. The only change is to marginal revenue, and now we're saying marginal revenue is actually different from demand, twice as steep. So we find marginal cost equals marginal revenue. We find the quantity, but the monopolist knows what the market demand is, and so they know the consumer's maximum willingness to pay for this profit maximizing quantity. What is it? It's shown by the demand curve. Here it's labeled average revenue. Demand does equal average revenue, but not a hugely important point for us right now. Okay, so here's our demand curve. Marginal revenue is twice as steep. To find the profit maximizing quantity, we find MC equals MR. That's right here. That gives us our quantity. And then the second step, now we found our quantity, we need to find the right price. The price we can find by plugging into market demand. So, right, here's our market demand. We know the quantity produced. This will spit out what the market price should be, or in other words, the consumer's maximum willingness to pay for this market quantity. Right, so MC equals MR gives us the quantity. That's step 1. Step 2, plug this quantity into the demand curve to find the price for that quantity. All right, so numerically, just a quick example here. Suppose that we have market demand as P equals 120 minus 0.02 Q. Monopolist has this total cost function. What are the profit maximizing Q and P for the monopolist? Right, so 2 steps. We're going to use MC equals MR to find Q star. So let's do that. Marginal cost, here's our total cost function, 25,000 plus 60Q. Find the marginal cost. We take the derivative of that with respect to Q. Gives us 0 plus 60. So marginal cost is 60. And we want to find marginal revenue. So 2 ways of doing that. We can construct total revenue and take the derivative, or we can just know that it will be our market demand, same y-intercept, twice the slope. Right, so we have marginal revenue, we have marginal cost, we set them equal, use our calculator and find Q star. And the second step, right, there was no second step in the perfect competitor because we were given the market price. We already knew it. In this case, we have to find the market price by plugging into our demand equation. What is the consumer's maximum willingness to pay for a quantity of 1,500? So we plug in, We get what our market price is. And now we have the information to construct the monopolist profit, price times quantity, minus the total costs. Here's our total cost equation of producing a quantity 1,500. 25,000 minus 60 times Q. All right, so we get profits. Unlike the perfect competitor, there's no free entry and exit. So a monopolist can produce positive profits in both the short run and the long run. All right, another example for you to look at. In the next video, we'll talk about why the perfectly competitive market is said to be economically efficient and why the monopolist is not.